part of what I want to do is actually show you how the web works on an architectural level. And so let me start with a browser. And I have a lot of tabs open, which is probably not great, but I just hit F12 to open the debugger tab in Chrome. And anytime you're doing web development, you're going to find this tremendously helpful, because in addition to being able to test out little bits of JavaScript that you might not know if you haven't studied JavaScript before, there's this network tab in the debugger that lets you actually look at all of the communication between your browser and the internet. And so let me go ahead and actually in this tab, I'm gonna navigate to pcc.edu. And that actually causes many, many separate documents to be fetched. And I thought I could resize this by grabbing it, but it doesn't seem to want to let me resize it. So, so I'm just going to grab this and resize it instead. So if I scroll up to the top here, the first thing that it did was it started fetching this app document, app origin equals blah, blah, blah. And that was actually when I opened the browser tab before I even started fetching a particular document. So here's where I actually typed www.pcc.edu into the address bar and hit return. And what it did was basically opened a connection using secure socket layer. So this HTTPS stands for Hypertext Transfer Protocol. And then the S is secure socket layer. And then : / this is the protocol. And then this is the host name that it's connecting to on the internet. And this is a text-based protocol that it's using for the browser to talk to a web server. And so in fact, if you have like Telnet or another text-based client that lets you make a remote connection to a machine, do I have Telnet on here? No. But I don't really need it. But if I had one, I could just Telnet to connect to port 80 and then send the literal text get space slash space HTTP slash 1.0. And that would be the first line of a request to the web server to give me the root document using Hypertext Transfer Protocol 1.0. And we'll talk about what GET method is in a second, but it's a simple text-based protocol where basically there's a set of header fields in a request, and then a blank line, and then an optional request body, which is used for posting data or for uploading files. And then the request header is sent to the web server, and the web server responds with a response. So here's my request. I'm accessing the root page on this web server with this host name using GET method. And then the status code of the response from the web server was 200, which is an OK status. So that means my request was found, the document was found. It also gives me some additional information, the IP address that I connected to, the port number of the web server, which is 443 for secure socket layer. It's 80 for straight by default and 443 for encrypted. And then there are some policies having to do with cross-site scripting, which is useful for security. So the actual response that the web server sent is here. Here's the request. So this view source, this is the actual text of what the browser sent to, and I just clicked on the wrong thing here, I think. Let me see if I can go back. Let me try this again. I accidentally clicked on the wrong thing, so I lost my position. Here I am. Okay, so this is the full request that the browser sent in straight text to the web server. And the importance, so this is the protocol it's using, or the method, which is get. This is the path to the document on the web server, which is slash, because it's the root document. And then this is the protocol that the browser is using to talk to the server, which is HTTP/1.1. And then there's a whole bunch of optional additional information that the browser sends to the web server that the web server is free to use to adjust what gets sent back, including this accept field. The browser tells the web server what kinds of documents it understands in response. It tells the browser that it can use compression. It tells the browser what languages it accepts. It manages the connection to the web server and can reuse it to send multiple requests and get multiple responses so that you save the cost of setting up new connections and tearing them down for each little bit of content. Then there are cookies, which are sent from the browser to the website and then back from the website to the browser on subsequent fetches from the same host and URL, or a subtree of the URL. You can specify where the cookie applies and doesn't apply, but each cookie is basically a key value pair, just like the dictionaries that we have in Python. So for example, there's a cookie key __ UTMA with the value 1648 and blah, this whole thing here. And then semicolon, and then the next key is this thing, and so on. So bunches of keys. Then this host here is the browser telling the web server what website it thinks it's accessing at this IP address. So you can actually have multiple different websites with different host names that are all on the same machine. And even though you're like talking about the root document of the machine at a particular IP address, you get back different content depending on what host name you supply in this field. And that's called virtual hosting. So basically you can have multiple websites that are all hosted on the same computer. And it's this host field in the request header that tells the web server what set of documents to send back for any particular URL. And then a bunch more stuff, including like this user agent is the browser telling the web server what piece of software is being used to access it. And then I don't think any of the other stuff here is all that important or interesting. And then the response from the web server looks like this. It's text-based as well. So the first thing it says is, okay, I'm talking to you using Hypertext Transfer Protocol version 1.1, and the status of the request is 200, which means the document was found and is okay. And then you get the date that the document's being served, the last time it was modified, and if it was a static document that's out on the file system, it will be the last modified date of the document on the file system of the web server. And then some stuff about what kind of information is being sent, including an expiration date for the document, and some whether it's cached or not. And this is an important one. This content length here is how long the actual response is. So the web page at pcc.edu, the HTML is 4,405 bytes long. And then this is also very important. This is the type of the data that's being sent back. And this content type indicates that the response for this document is it's a text/HTML document. This is called a Mime type, and Mime is for um, uh, basically multi-part email protocol. What does it actually stand for? Hold on. Mime. Multi-purpose internet mail extension. Basically, it's an old standard having to do with when attachments were added to a mail message. And as part of the attachment, the mailer needed to know what kind of document was being attached, so it could be downloaded or displayed correctly. This protocol was developed as a way of specifying the document type. So basically all of this stuff for the hypertext transfer protocol was based on earlier protocols for sending multi-part email messages. And anyways, that's this part here. So it's HTML document. The char set is UTF-8 Unicode, 8-bit byte Unicode. And then I want to emphasize that this is the only way that the browser knows how to display the information, is this content type here. So if I wanted to send back a JPEG, I would send back content type image/JPEG. So for example, let's see if I have a JPEG here somewhere. Well, here's an SVG. Oh, here's a JPEG. So if I look at this JPEG, the response header on this thing, content length is 25K. It's just going to be data. This is the thing that tells it that it's a picture. So why do I display the HTML as HTML, but display the picture as a picture? It's because of this content type field that the server sends back in the response header. So it's up to the server to actually make the determination of what the content type is. And the server may use the extension to do that, or it may use the binary contents of the file, or there may be some other mechanism. So that's an important part of the communication. And then after the response header, there's going to be a blank line and then the actual data, which could be one part or it could be multi-part with boundary lines between each part if it's a multi-part message. And once again, that comes from old mail protocols where you would have an email message that might have multiple attachments to it.